In the last video on interfaces, I basically introduced the idea of interfaces and created this simple example where I had one interface called movable with a single prescribed method move. I had a second interface, deletable, with a single prescribed method delete. And then I had a shape object, a public class shape, which implemented both of the movable and deletable interfaces, which required me to provide implementations for both of those methods. Okay, so in this video, what I'm going to do is I'm going to show you some interesting things that I can do now that I have these two interfaces and this object. So I'm going to create a new class here. This is going to be my class with my main method in here. So public static void main. Okay, and what I am going to do in here is I'm going to actually create some shape objects and things. Okay, so if I do shape s1 equals new shape, all right, if we go back and look at our shape object, we see that, well, I don't really have a constructor. I don't really have any attributes. All I have are these move and delete methods, okay? So this is all fine and well. I have this shape object, and I can, I can do s1.move if I want to, and I can do s1.delete, okay? And you will see that, I can save this, and I can run it, and nothing particularly interesting happens. It just calls those methods. I am moving and deleting something. Okay. Now, here is where the whole point of interfaces and polymorphism and stuff all come together and why you would even do something like this, all right? I can do this, all right? I can say movable. I'm going to do movable, and I'll just call this m equals new movable 5. Okay, so this is a line that basically says go create me an array of movables. Now you might be saying to yourself, wait a second, how can you create an array of an interface? Okay, well, this is where polymorphism kind of comes into play here. Okay, I'm not really creating an array of interfaces. What I'm creating is an array that can store objects which implement the movable interface. Okay, so I can compile this. You'll see, and that compiles just fine. Now, what I can't do is I can't do this. Like, let's say that I want to do m sub 0 equals new movable. Okay, well, remember, movable is an interface. It's not a class. Okay, so I can't actually instantiate one of these. And you'll see that if I compile it, it in fact says that movable is abstract, cannot be. Okay, this is an interface. It's not going to allow me to do this. All right. But what I can do is, again, anything that implements the movable interface, I can create an object of. Okay, so we know that shape implements movable, so I could do new shape. All right. Now, suppose that I have, let's go ahead and create, we'll do a public class rock. Okay. And this one we're going to make not implement movable. Okay. It's not going to implement anything. It's just going to be like this. Okay. So if I do that, all right. Now, if I go back here and I try and do m sub 1 equals new rock, all right, what do you think will happen? Well, it gives me an error and it says, nope, rock cannot be converted to movable. So in other words, I'm allowed to create this array of movables, okay, even though movable is an interface. And the only things that I'm allowed to put in here are objects that actually implement the movable interface. So shape does implement the movable interface, whereas rock does not implement the movable interface. So rock's not allowed to be in that array. Okay, so I cannot do this. All right. Now, the interesting thing about that is now I have this array of movables, and just like with superclass references and some of the other stuff that we went over during inheritance, now I could loop through this array and I can execute any of the methods that are associated with movable. Okay, so in this case, the only method that I have that's associated with movable is move. So if I were to loop through this array, the only thing that I'd be able to do is call that move method. Okay, despite the fact that I have this shape and there are probably other things in the shape that I could do. But the nice thing about that is that now I have a way of sort of referencing just the specific portion of these objects that I want to, in terms of, hey, maybe I have 1,000 shapes and I want to move them all. Okay, then I could just very simply write a loop, call the move method, and then I would be fine to go. Okay, so likewise, I could do the same thing with deletable. Okay, because that is also okay, and I could do d sub 0 equals new shape. Again, deletable is this interface, okay? And I can go in here and I can create an array of things, and then I can assign any class or any object that implements the deletable interface can be then assigned into this slot in the array, okay? Now, I want to point out something here really quick, okay? Let me go, we'll just stick with this example, okay? If I try and do d sub 0, which is a deletable, okay, dot move, what will happen? Okay, well, remember, even though d sub 0 is actually a shape object, okay, I'm referring to it in a deletable kind of context, or with a deletable reference, okay? So that means the only thing that I'm allowed to do in this context, with this deletable context, is deletable methods. So the only thing that I'm allowed to do is call delete. So if I were to try and compile this, okay, you would see that it says, I don't know what you're talking about, can't find the symbol move because you're talking about a deletable and there's nothing called move in deletable, okay? So in other words, I cannot do this, all right? But I could do d sub 0 dot delete, okay? And you will see that that compiles just fine, all right? So this is, again, another way of, I guess, using polymorphism, these interfaces. This is how you can create objects that are very flexible and very usable under lots of different circumstances. So if you were thinking of a game, like a video game, for example, you might have an object called an enemy or a player, and you might have interfaces of movable, deletable, killable, hittable, invincible, right? Anything, any sort of behaviors associated with that particular game, you could then implement those. And then as you're working through the logic of your game, you could put in methods where you basically say, hey, I'm going to go loop through all of the items that are movable and move them. I'm going to loop through all of the things that are hittable and, hit them, or, reduce their hit points or whatever, okay? So this is why you would use something like this, all right? So that's, I guess, kind of a basic example of sort of some of the things that you can do with these interfaces, and how, even though I have this just shape object, the fact that I implement these different interfaces, movable and deletable, means that I can refer to that shape in lots of different contexts. I can refer to it just as a shape. I can refer to it as a movable. I can refer to it as a deletable. And then depending on how, how I want to access those properties and methods and things, I can refer to it in the correct context in order to do so.